Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by cutting power and confirming 0 voltage at the saver. This prevents shock and avoids component damage. Once power is off, photograph internal layout so you can reassemble correctly and label connectors. Use a multimeter to check supply and fuses. Why? It isolates simple failures fast. Then remove the cover and visually inspect for burnt parts, leaking capacitors, or loose wires. Make sure to use insulated tools and a parts list so you don't improvise. You now move into systematic diagnostics. Measure capacitor microfarads, check relay coil resistance, and verify thermal switch continuity so you know which component failed and why. Once you identify the bad part, desolder or unclip it carefully. Apply heat evenly to avoid lifted pads. Replace with equal spec parts because ratings affect lifespan and safety. When soldering, make clean joints and reflow existing pads. After replacements, recheck the same readings to confirm the repair before reassembly. You reassemble in reverse order. Align connectors and torque fasteners snugly so vibrations won't loosen them. Once done, restore power and monitor inrush current and output voltages while running a normal cycle. This confirms operational stability and safety. If readings are off, make sure ground and neutral are correct and recheck replaced parts. A key troubleshooting tip: if intermittent faults continue, substitute the control module with a known good unit to isolate wiring versus board failure. This saves.
Thanks for watching. Subscribe to keep your life in tune.